In this example of a configurable sectional door, we want to demonstrate the power of the Tacton Design Automation solution, which is available as an add-in for Solidworks. In order to configure a variant of this sectional door, we first start Tacton Design Automation Engineer. We see the user interface, which allows us to control, for instance, the size of the door. We start with a clear width and change it to 5,200 centimeters. The height will be increased to 3,900 millimeters, and the roof angle gets a 12-degree inclination. Look at these mounting brackets. Currently we have only 4. Now we update the model to see the desired changes. All the geometric changes have been performed, but we also see that according to the bigger and heavier door, we now get 6 mounting brackets for the glider rail. This is the first example for a technical rule inside our Tacton model. Now we concentrate on this red servo motor. As we can see in the Solidworks feature tree, the model used here is engine P1, which does the job for this size of the door. What happens if the door width increases in size to, let's say, 6,500 millimeters? According to the rule work behind this assembly, we will automatically get a stronger servo motor then. And as you can see, this is done by really replacing the Solidworks part. This drive is blue and the component name is engine P2. For this particular building, there is no place for the servo motor and the controller box at the left-hand side, so we just move it to the other side. This would take us some effort with pure Solidworks, but with Tacton it is done with 3 mouse clicks. Let's look at some other aspects of the door. We want to have some daylight in the building where this door should be mounted. So we choose to have small windows in section 4, 6 and 7 counted from the ground. Notice that we do not only get the windows, but rather also the apertures for them in the section surfaces. According to the current door width, we get a pattern of 12 windows in each row. When we think about having a pass door inside the sections, it gets even more interesting from the designer's perspective. As soon as we click the Yes button for the pass door, we immediately get some new menu items regarding size and position, where we first choose a width of 900 from the drop-down list. We set the height to 2200 and press the Update button for getting the result. The pass door appears at the right-hand side first, which is the default. We change it to a center position now. For the user again, this is only a mouse click, but think about how many changes are needed internally and how much work it would take to do these changes manually. Of course, the window distribution has adapted and we now have 2 patterns of windows here. The last aspect of this movie will deal with the control of the door color, as well with the material of the guide rails and the fittings. We choose galvanized steel for the fittings and rails, and gentian blue for the door itself. After pressing the Update button, we can clearly see that both material and color have changed as desired. Checking for doublets, assigning new file names from number generators and exporting the result files into a PDM system is done by Lino PDM Pro, which will be shown in detail in a separate movie. Thank you for your interest in our solutions.